Hello again. We're going to go over what will now be topic for Lab 4. So this will be an example of how we get into the Arduino and start teaching the students a couple of things, because it's really important throughout this whole semester to reinforce to your students that we are not here to teach them in the same way as we are now having to teach them how to learn. And that's the big difference that we need to really make clear as our expectation. Is it's not about us trying to shove the knowledge down into their heads. That's not actually our jobs, and that's not a thing that we can do reasonably, specifically in fall of 2020, for a whole wide range of reasons, not the least of which is all of the COVID-idiocy running around as a result of all this madness. So what we need to do is we need to reinforce that we're teaching them how to learn. Well, how do we do that? So Lab 4, they're called out to develop a binary counter because of a debate that I have with a colleague who should remain unnamed. So whether this colleague is real or fictional is up for you to decide, but it makes for a pretty entertaining backstory for the reason that these students have to do this, because instead of taking out our dry cleaning, settling a bet seems pretty logical, because nobody does dry cleaning anymore or something. I don't know. The point is, what we're going to do is we're going to start taking a look at some of the fun and interesting aspects of how to start incorporating an Arduino. So what I would recommend is jumping over to, actually for this one, I think you can just use the simple basic components. We're going to add in Uno R3. So this is going to be the same type that they're working on in their kit. We're going to add in a breadboard. You don't strictly need the breadboard. I'm going to hit escape there real quick to drop that off. I have a dirty contact in my switch, so I get a double click or a single click depending on exactly where I click the mouse button. Makes life very interesting. Keeps you on your toes. So what we're going to be doing is taking this, we're going to be wiring over to a few of these. So there's a bunch of little things going on. One of the things we're going to do is we're not going to go crazy and do RGB LEDs. We're just going to do simple LEDs. I'm actually going to wire them down here on the board, and I'm going to move this whole board up to make things a little bit easier for the students to see in terms of kind of visualizing things. I'm going to try and more or less line up the breadboard with some of these wires just to keep things simple and clean in the routing. Because one of the things that I want to start teaching them digitally, and part of the reason why I really like using this tool, is I'm teaching them digitally to think about wire management in a way that they wouldn't naturally think of, because they just want to get it connected on the board and get it to run. Here, you can actually think about the wire layout and management, and how are you going to actually run your wiring, especially as projects get to be more and more complicated throughout the semester. In this case, I'm just going to set up a 4 LED example of a binary counter, and you can copy paste items. So I can come up here and I can do Control C, Control V, and I've got all of these. Now, when they're in the breadboards, obviously you don't have to connect the LEDs or whatever, the potentiometers, light bulbs, capacitors, all of the microcontrollers, whatever it is that you're using in the breadboard. You don't have to connect it to the breadboard with a wire. It'll automatically assume it's connected. I use these little green highlight bars to help students start thinking in terms of, oh yeah, these are all connected, same way that these are all connected. When I look at these, if I bring power into anywhere on this rail, the whole thing has that same voltage applied. Same thing with the ground rail. So it's really set up to help the students succeed and help make this super accessible. And this is one of the instances where, especially if they've gone through the tutorial, they've got some idea what some of the code may look like. What we're encouraging the students to do, and if you don't want to use this 4 binary counter and you want to use a larger one, one of the ones that what I may do essentially is I may take this and make it a little bit larger binary number set in order to work with a particular video that I like to use in class for Bender, one of the cartoon characters from Futurama, which the students all appreciate, and until probably another 2 or 3 years from now, and they won't even know what Futurama was. So yeah, getting old sucks. Anyway, what we're going to do for this is it's coming from the same exact thing. Instead of me spending a ton of time developing the code from scratch and working you through how all that goes and making a couple hour long video that bores you too to tears, what I'm actually going to do is do the same thing that I'm encouraging the students to do. We're not trying to get them to understand from scratch how to do programming, but we're getting them to start seeing how they can use somebody that's already developed the code for this. And so in this case, I'm going to probably use this example where it's counting upwards to do a binary display using this. And this is all the code. This is all the stuff that I need. This particular one is on a site called Multi-Wingspan. There's a gazillion of these tutorials out there. If you search Arduino LED binary counter, you'll get a bunch of different results. Use your favorite one. If you want one that has, like 12 or 13 LEDs, you can do that. It's just a little bit more work in terms of the actual setup for which pins are going to be input, output, and some of those things. So if you've never worked with Arduinos, don't worry, they're really not actually that scary at all. So let's jump into the code. They have the option to include things like code blocks. Honestly, I just haven't spent the time to make heads or tails of code blocks because I don't think in terms of code blocks. If you use this and find it very effective or find it much more intuitive and allow the students to see how this goes together, great, awesome, more power to you. I prefer the text specifically. And so what I'm going to do is I'm going to go ahead and wipe this out because I don't need it. And what we're doing is we're setting up an array of LED pins. So first step, there's 3 core things that you want to make sure that the students understand for any and all circumstances. The 3 core things that you're doing with an Arduino is you're initializing. So that's step 1. You're always telling the pins what they're going to be, what they're going to be called, essentially. And so this is an array of LED pins. They're using 7, 8, 9, and 10. So 7, 8, 9, and 10 are the ones that we're going to be using. We're not getting into PWM functions and complicated fancy stuff. We're just treating them as digital I/O, so digital input output. And the idea is we're turning that pin on or off, like a 1 or a 0. And that's why this lesson specifically is such a great one to teach them binary, so they get to see it with the LEDs. And they get to be able to work with it in terms of how to do switching pin states to high and low. And so they get to think of high has power, low is off, and just flipping it like a switch. So it helps to kind of bring a few of these different concepts all together and hopefully make it gel for the students. So first one is going to be 7 that it's connected to. So I'm going to bring this over a little bit. There we go. So we won't quite have perfectly clean routing of wires, but we'll be fairly close, close enough to work. So what I'm going to do is I'm just going to bring this in to right here. So this first one I'm going to do as red wire. The second one I'm going to do over here to 8. All of these are going to go to the positive side. Guess green is fine. This one I'm going to do to orange. This is going to be for this one, and then for pin 10 I'm going to set this up as yellow wire. Why not? All right, so we have 4 different wires. What the board is going to be doing, and the way that this code is set up, is it's set up instead of switching in grounds, what this is going to do is switch in 5 volts, which for most of the circuits that you're going to be doing, switching in 5 volts instead of shutting it to ground is probably going to be the right strategy. So just in general. Now, what I'm also going to do is I'm actually going to pull kind of a neat little trick, again, getting the students to think about wire management. So I'm going to drop the code out. I'm going to make this invisible for a second. We'll come back to this because I'm focused on building the circuit first here. So the resistor itself, I'm going to use to connect straight across, no extra wires or anything else to make things silly. So this, I'm going to do about a 300 ohm resistor. I'm going to copy that and I'm going to paste in a few other examples. So when you hit paste, it'll automatically show up on your cursor. And what this does is this can start to get students thinking in terms of, hey, I can use a resistor as a jumper wire. And there's lots of little tiny things that the students can start picking up on when you do something like this. So what you want to do is some of these factors, and you want to pull together some of these points here, is we'll be able to do this, that, and the other thing. Lots of stuff going on about fall course planning. Ignore the emails. We're trying to sort this out so that it's least headache for everybody. This is a royal mess. So now what we've got is we've got this set up. We still need to ground the whole board, but we have a ground pin here that we can pull from. So in this case, I'm going to bring this guy just straight up here, as simple as can possibly be. And now my board, my whole rail for negative, is grounded to the board. And the wiring routing is very clean, very simple. You don't have to do all kinds of crazy bends and things. We're just trying to get the students functional and understand how to cleanly put together a circuit that works. So let's go take another look at the code. If you left click and drag, you can move the whole apparatus, whatever your entire circuit is. You can move the whole entire picture, as it were, or the whole board, the whole desktop, whatever you want to think of this as. You can move the whole thing over out of your way. So we talked about three things. So let's talk about the other two, because my brain works out of order and it drives other people crazy. We start by initializing. So we tell the pins what they're going to be. Who are you and what's your job going to be? Number two is we set those up. So we have two different two different void loops that we're going to set up, or two different classes that we're setting up. So the first is an actual setup where we're saying, hey, this is what we're going to be doing. So for each of these cases, and in this case, I could do more pins just by adding additional pin numbers here. So I could also include 6, 5, 4, 3, 2, 1 in this group. And then I could have 10 pins and I could update this. And that's one of the kinds of things that you want to encourage students to do is, how would I modify this code? Not how do I write it from scratch, because that's going to absolutely scare them to death. Because a lot of these students, if you ask them beforehand, will be intimidated by code. But that doesn't need to be that way. This makes it very, very accessible. So what are the names of the pins? That's number one. That's what you're telling it. Number two, you're going in and telling it, okay, now what are the pins going to be doing? What's their job? So first name, second job. What's the job they're going to be doing? They're going to be doing the job of output. So these pins are going to be kicking power out of the board instead of looking at what's coming into the board and being an input pin. Okay? Real simple. And all it's doing here is just using some loop logic. This is stuff that they'll learn later on in CST 211 in much more detail, but this will get them some exposure to be thinking about, oh, so that means that from 0 to 4, in this case, because numbers start counting in a lot of loops and iterations at 0, it's actually 0, 1, 2, and 3. That's your 4-pin count. That's also why pins start at 0 on this. So lots of things that you can talk about, lots of learning lessons. And we're not trying to walk the students through an example of how to do all of this step by step. I'm trying to teach you as instructors how to go through and develop this for yourself so that you know where students are going to get stuck and what to encourage them to look for. But I do want you to understand the way that these loops are set up. So the void loop is the first one that's actually running the program. And so the loop itself is what it's going to do is say we have a byte counter. We're going to go from 0 to 15. And one of the other things that we want to encourage the students to do is change the code that they find in the tutorials they're looking for to make it do different stuff. Add another LED to the list and change the number of binary numbers that it can count up to. That's a great exercise for them to take a piece that they didn't know anything about before the start of this lab, possibly. Most likely, most of the students will not have had exposure to this. A few of them will. The ones that do, encourage them to go crazy and go as complicated as they possibly can. The other students, you just want to get them thinking about, well, if I change the number here on the counter, then I can go from 0 to 20, then I can go from 0 to 30, then I can go from 0 to 100 and see what that looks like. And so in this case, we also have a display binary. So this first one is setting up the byte counter, and it's going from 0 to 15. So it's doing a total of it's doing total here of 15 loops because it's a less than or equal. So a total of 15 loops. It's doing display binary. So this is the function that it's calling. And this is the function down here. So what it's doing is it's taking a number from this byte counter, and it's saying, okay, what we're going to do is we're going to go from 0 to 4, and we're going to read it, and then we're going to set the pins. So we do a digital write. Digital write and digital read are two very important commands, and that gives you, I don't know, like 40% of what you're ever going to do in Arduino code is a digital read, a digital write. It's really that simple. So writing tells the pin, hey, I want you to do this job now. Write it high, that turns it on. Write it low, that turns it off. And by setting it up in this, if there is a bit to read from this loop up here, if there is a bit to read, then you write it. The pin goes high for that specific number if it's comparable to 1. So it's either going to be a 1 or a 0, and that's what it's reading. So it will count up, and it'll have a delay of 500 milliseconds or a half a second in between. So let's watch what this actually looks like as it executes. What it's doing is it's counting up in binary numbers, and then it starts over and counts up. And by delaying that 500 milliseconds, we can see what's actually happening and see the numbers. And one of the ideas is we want to get them to think about, okay, how would I get it to display a specific number